Hi guys, I'm Lisa, your online Calc tutor, and today we're going to talk about the free response questions from the 2019 AP Calculus BC exam. We're going to do number 3 in this video, and I'll be posting videos of all the other questions as well. So let's jump into it. So we're given a graph of a function in this problem, and we're told that the continuous function f is defined on the closed interval -6 to 5. Notice that the graph only includes -2 to 5. So from -6 to -2, that's not pictured. And then we're told that the graph consists of 2 line segments as well as a quarter circle. And the circle has a center at 5, 3. And so, just so we can kind of picture it, if we were to draw in the rest of the circle, it looks something like this. So it's a quarter of that circle. And we're also told that the point 3, 3 minus root 5 is on the graph of f. So they're telling us about the specific numerical value of that point there. So let's jump into part A here. So we're told that the integral from -6 to 5 of f is 7, and they want us to find the integral of -6 to -2. That's the portion that's not pictured in the graph. So if you recall your properties of integrals, we know that when we integrate a function over an interval, we can split that interval into several pieces and write those as separate integrals. So for example, -6 to 5, we can say, well, we can split that into -6 to -2 plus -2 up to 5. Okay. Now the integral from -6 to -2, that's what we're solving for. And -6 to 5, they told us that's 7. So I'm going to write that. This is what we're trying to solve for. So we're going to need to use the graph to evaluate, didn't write this in. Do that. So we're going to need to use the graph to help us evaluate this integral here, the integral from -2 to 5. So a definite integral, of course, represents an area, the area between the curve and the x-axis. So I'm going to go ahead and color in what those areas are. And in this example, we can see that some of these areas are actually going to cancel out, right? Because when the curve dips below the x-axis, that area is counted as negative, right? So like between -1 and 0, that green triangle is going to count, the area of that triangle is going to count as negative for the purposes of calculating the integral. And we can see that that triangle from -1, from x equals -1 to x equals 0 is the same shape and size as the triangle from -2 to -1. So those actually cancel each other out perfectly, and that contributes 0 to our total answer. Same goes for the orange regions. Those triangles are the same size and shape. One is going to count as negative, the other is going to count as positive, so those are going to cancel out as well. So the other regions that we would need to find the area would be this light blue here. And that can be, so we can see that, you could do that, you could treat that as a trapezoid, but I think I'm going to just split it into a square and a triangle. So the square has side 1, so that's going to have area 1. The triangle has a base of 1 and a height of 2, so it's also going to have area 1. So the light blue region is going to have total area 2. And then the remaining part is going to be this, the part that's under the quarter circle. Now, how do we find an area like that? We're going to use, it's kind of the negative space, right, that's created by this quarter circle. So we can say that that pink part is going to be the square minus the quarter circle, the square between x equals 2 and x equals 5 and y equals 0 and y equals 3. So I'll just draw that in. Right? So the part underneath the circle is going to be the square minus the quarter circle. The square is a 3 by 3 square, so that's going to have area 9, and the quarter circle, so it's going to be pi r squared divided by 4. The radius of that circle is 3, so we're going to get 9 pi over 4. Great, so we've evaluated that integral from -2 to 5 by calculating areas, and now we just need to rearrange this a little bit and consolidate to get our answer. So it's going to be 7 minus 11 plus 9 pi over 4. And so 9 pi over 4 minus 4. So that's our answer for part A. Now let's move on to part B. So I've just included again all the introductory info so we can refer to it for part B. So here they're asking us to calculate the integral from 3 to 5 of the function 2f prime of x plus 4. So here we're going to use properties of definite integrals as well as Fundamental Theorem of Calculus. So definite integrals are linear, right? Which means that this 2 can be pulled out. And also we can separate into 2 integrals across this plus sign. Right? So this is going to be integral from 3 to 4 of 4 dx. So Fundamental Theorem of Calculus says find the antiderivative. Antiderivative of f prime is just going to be f, and we're going to plug in our limits of integration into that. And same goes for this other integral. Antiderivative of 4 is 4x, and we'll plug in the limits. So we get 2 times f of 5 minus f of 3 plus 4 times 5 minus 4 times 3. And we just need to, so we're going to need to find f of 5 and f of 3 using the graph and the given information. So f of 5 we can see on the graph is 0. Now f of 3, so that's over here. It's hard to read it from the graph, but that's actually the point they told us about, right? They told us that the point 3, 3 minus root 5 lies on the graph. So f of 3 is going to be that, 3 minus root 5. And then this is going to be 20 minus 12 here. So again, we can just simplify this to get our final answer. So I'll go ahead and distribute this negative sign into here, multiply by 2, so I'm going to get -6 plus 2 root 5 plus 8, and then if we simplify that further, we'll get 2 plus 2 root 5. So that's for part B. Now let's go to part C. In part C, they're defining a new function g of x, which is defined to be the integral of f between -2 and x. So this g of x is going to be basically an area function under f. It says find the absolute max value of g on the interval -2 to 5 and justify your answer. So here we're going to use the method to find an absolute extrema of a function on a closed interval. So we're going to locate critical points of g in the interior of the interval, so in -2 to 5. So we want to know where g prime of x equals 0 or is undefined. Now, g prime of x, so that's going to be the derivative of the definition that they gave us. So you might recognize this expression as an example of Fundamental Theorem of Calculus Part 1. We have a definite integral of a function where we then have a variable in the limit of integration, and then we're going to take the derivative with respect to that variable in the limit of integration. That's going to be FTC Part 1, and so g prime of x is actually just going to equal f of x. and we want to know where that is 0 or undefined. Now, so g prime is just f, and of course f is pictured in the graph, and we know that f is actually defined everywhere on this interval, so there's not going to be any places where g prime could potentially be undefined. So we're going to only have critical points where it's equal to 0, and we can just read this off the graph. Where does the graph cross the x-axis? We can see that this occurs at x equals -1, and also at x equals 1/2. And by the way, I'm not just eyeballing that. We know that this is a straight line, and we can see that it has a slope of 2, so we can say precisely that, yes, x equals 1/2 is exactly where it crosses. And then, so we've identified our critical points. We're also going to include our endpoints as potential x values where the absolute max could occur. We're going to create a little chart here to determine the values of g of x at these possibilities. And then, pick out the largest one, which will represent the absolute max. So I'm going to put in for my values of x, -2, that's an endpoint, -1, that's a critical point, 1/2 is a critical point, and 5 is, there's like a little gnat in here, it's flying around. So you see me swatting at something, that's what it is. So here's our x values. And we want to find g of x for all of these 4 values. So g of -2, that's, so maybe I'll just go over here and write this so we can see how we would calculate. So g of -2, I'm just putting -2 in for x in the definition. Right, now you can see that this is an integral with the same limits, same upper and lower limit of integration, so that's automatically 0. Okay, so I'll put that in. G of -1, again, I'm just subbing that in using the definition we were given for g. So this is going to be an area under f between -2 and -1, and we can see that that's a triangle, right, with a triangle above the axis with base and height equal to 1, so the area there is going to be 1/2. Okay, and then next we want to do g of 1/2. So again, kind of harkening back to part A where we were looking at this, we know that the area between -2 and 0 is going to be 0 because we have this triangle which is contributing positively to the definite integral, and this triangle here, which is contributing negatively, and they are the same size. So that actually cancels out. So the integral from -2 to 1/2 is just going to be the area of this little triangle here, but negative since it's under the axis. It has a base of 1/2 and a height of 1, so its area is going to be 1/4, but it's going to be negative. So -1/4. And then finally 5. And actually this is something we already calculated up in part A, right? We already calculated the total interval between -2 and 5, and we found that that was 11 minus 9 pi over 4. And so, okay, so these are our 4 values, and we just have to pick out the biggest one. And the biggest one is going to be this one. And you can just double check just to make sure. You know, pi is a little bigger than 3, 9/4 is a little bigger than 2. So this is about, it's a little bit bigger than 6. So 11 minus 6 is about 5, much bigger than 1/2. So this is definitely going to be the absolute max. And if you look at the question, they're saying find the absolute max value of g on the interval. So if you kind of pay attention to how they're asking that, they're not asking us for the x value where the absolute max occurs. They're asking us for the actual absolute max value of g. In other words, they want a g value. So that's what they would give us. So your actual answer here is going to be this number, 11 minus 9 pi over 4. Okay, great. And then let's go to part D. So part D is a limit. Now when you Generally speaking, when you evaluate limits, a good first step is just to try to plug in the number. Now, most of the time, for most limits, you might get some kind of an indeterminate form, like a 0 over 0, or like a infinity over infinity. But occasionally you will just actually get a numerical value, which is what's going to happen here. So we're just going to plug in 1 for x here and see what happens. So I'll just do that. F of 1 minus arctan 1. So we're going to need to find the value of f prime of 1. So when x equals 1, the graph of f is a straight line there. So the derivative at 1 is simply going to be the slope of that line. And you can compute the slope of this line by doing rise over run, change in y over change in x. If you use the 2 points 0, -1, and 2, 3, you can see that the change in x is 2 and the change in y is 4. And 4 over 2 is going to give us a slope of 2. And we're also going to need f of 1, so I'll just go ahead and write that down as well. F of 1, you could see is 1. So great, so let's just plug these in. So this is 2, and this is 1 minus arctan of 1. This is a non-calculator question, so we need to evaluate arctan 1 without the use of a calculator. So arctan 1, so that means we want to find the angle whose tangent is 1. So in other words, if arctan 1 is equal to z, that's saying that 1 equals tan z. So what angle has a tan of 1? Well, that's saying where is sine and cosine equal? And that occurs at pi over 4. Okay, so we'll just put that right in there. And that's basically your answer, but you can clean it up a bit if you like. You could leave it like this. I'm going to go ahead and multiply top and bottom of this fraction by 4 just to get rid of the fraction within a fraction. So if I do this, I'm going to get 16 over, if I distribute the 4 to this expression in the denominator, I'm going to have 4 minus pi. And that is the answer to part D. So I hope you enjoyed this video. I hope it was helpful in understanding this question. And I will be posting soon the other questions in this free response section, and probably also some from previous exams as well. So if you have questions or comments, feel free to leave those in the comments section below. And I hope you really enjoyed this video.